Hey guys, good morning. How's it going? If you're able to hear me loud and clear, give me a hi in the chat box. Hi Noel, good morning. Hi Alicia, good morning. So today we're going to start with the actual matter. We are done with the stories behind CCNA and everything you need to know, the context behind you doing this and all that, right? So I hope you guys are clear about what we discussed yesterday. If you have any questions, you can pop them out in the chat box, or you can give me a yes. We are clear, so we can move forward. Awesome. So, and I was hoping to be able to make maybe tomorrow onwards the lectures that we are going to have into maybe a meeting style thing where I don't want you guys to come on camera, but I'd really like for you to have the opportunity to ask me something if you want. Like you can probably have your mics strapped on, or maybe your earphones, and if you have a question, you can ask me. So would you prefer that, or would you prefer the webinar style thing that we are doing right now? I'll tell you the pros and cons. That meeting style thing would be a little more distracting. The webinar style thing is free of interruptions. I mean, there is no other screen to look at apart from that. And that is also part of the reason why I am not on camera, because video, for me to come on video is not a big deal. I do this for a living, but it again becomes distracting, and you need to focus when you are learning something like the CCNA. So do you want a webinar or do you want a meeting style thing? I just want to get your opinion before we move forward. Okay, Noel says webinar, Alicia says webinar. Okay, let me know anytime you guys want to change, because I really don't mind. So give me a second and I'll share my screen with you. So if you guys are able to see this, what do I call it? Colorful looking presentation, please type in PPT in the chat box. Okay, great. So let's start with some networking fundamentals. Now, question number one, what is networking? And when I say networking, networking is a very broad concept. There is like computer networking, which we are going to talk about for the next 30 odd days. Then there is, social networking, where you, mingle with people from your own network. You try to find jobs, try to help people, solicit business. So, and then there's network marketing, which is like, kind of like you try to sell stuff, under your own this thing. You get into sales and marketing and all that. So basically, when I say networking in our context, it means that we are going to talk about computer networking. Now, when we talk about computer networking, it means that there are devices, and I'm just saying devices. I'll explain what these devices are in a second. So there'll be devices which are connected together, and the whole purpose of us doing it is like we want to share information or common resources. Now, what type of resources, what kind of information? So maybe you want to share data, like there is a file, there is a folder, you want to share it from one PC to another one, and both these PCs are in the same LAN, or the same local network right next to each other within the same organization. While on the other hand, you can have two systems which want to exchange files and folders, and they are, maybe you have a branch office in Goa and the other one is in London, right? So you still want to share files. So there is a way to do that as well. So this is a business requirement, right? So networking is going to enable this, right? So when you want to share software applications, right? A typical example I'm just going to show you now with a diagram. You'll also be sharing software or applications. You'll also be sharing hardware. For example, you may have one common printer across maybe a small office like 50 people or 20, 30 people strong. So you don't need 20 printers for 20 people. You just need one printer, because it is something that you don't need every minute or every hour. So you'll share this one printer across maybe 20 people, 40 people, 100 people. So you save on costs. And you accomplish that using networking. So your PC is going to communicate to the printer and give it the print job, and you're going to get the printout. And 100 other people are capable of doing this at the same time, right? That is a typical example of networking. Now, servers, like you will have your web server, that is your website servers, your email servers that are like, I've got a slide on servers coming up shortly. So there are servers, you'll have 1 or 2 or 3 servers for your organization, and maybe an organization of 1,000 people is sharing those servers. That is also networking. So you're sharing resources, right? And you also are sharing internet. Say, for example, now at your home right now, you have a single internet connection, right? But you are likely having more than one device online, maybe your phone, maybe your laptop, maybe your family members' phones. Maybe any given time, on an average, you're likely to have about 6 to 8 people connected online. But do you think you have 6 to 8 connections from your ISP? Not really. You have a single connection, and that single internet connection is being shared across multiple devices. That is also, you're sharing a service. You're sharing what is available across multiple devices, right? So all of these are examples of networking. So computer networking is the study of how you're going to plan. First, you have to plan or design them, and then install, and then configure, and then maintain, and then troubleshoot. Troubleshooting is when something goes wrong and you make it right, right? And how are you going to do all of this for computer networks? That is computer networking, nothing else but that. Now, there are some types of networks I just want you to know about. These are common whenever you go through some manuals or you look for resources online. So you're going to come across these devices, these terms or terminology. So I want you to be extremely comfortable working with them, right? So enterprise networks are nothing but large-sized corporate networks. So when you say enterprise networking, it means the kind of networking they use, the kind of structures they use, the kind of devices they use, protocols they use, everything, but for big-sized companies. So maybe typically more than 100 systems, maybe more than 1,000 systems. When you talk about SOHO, SOHO stands for small office, home office. So small office, home office, this is a term used to denote maybe a small size, maybe people are working from home, right? This pandemic, that is also a small office, home office. And people have been working from home from before the pandemic as well. Many people, like freelancers and a lot of people, right? They have the businesses where they operate out of a computer. That is a small office, home office. All they need is the internet and a laptop. That is small office, home office. And maybe there is a lawyer, maybe there is a consultant, and all he has, maybe the lawyer has, is like 5 to 6 legal interns, or maybe the consultant has like 2 people working under him for the back office and the administration tasks. So likely these are also small office, home office. He's not likely to have a very big setup. He'll have a small, maybe wireless router. I'll show you these diagrams. Small wireless router, and all the devices are either wired or they are wirelessly connected to the wireless router, and they are all sharing the internet. Typically very similar to how your home connection looks like. This can be typically about 10, 15, 20. I mean, 20 is a big thing, but the kind of devices you use for 20, 30, 40 systems would be a little different than the one you're using at home. Okay, but you get the point, right? So all of this comes under small office, home office. So if I have a small, maybe a call center of 20 people and just running out from a small space, that is also SOHO. And it is also called as home broadband. Now, SMB is small to medium business. So SMB is something like which falls between SOHO and enterprise networks, right? So SMB is small to medium business. That is the SMB is the acronym for that, or the short form of that. And it is meant to denote medium-sized networks where you have maybe more than SOHO, but less than enterprise. So this is what your typical, SOHO LAN or small office, home office LAN is likely to look like. Just to give you an example. So there will be one, When I say internet cloud, I mean the connection coming in from your ISP, which connects you. So this connection is basically from your router. The connection goes to your ISP network, which then connects to another ISP, which then connects to another ISP, which then connects to another ISP, and so on and so forth. And finally, it will connect to your destination, wherever you want to go, maybe google.com, maybe yahoo.com. Maybe you want to connect to, your office in New York. Maybe your office in New York is here. And this is the system, right? So your internet is nothing but a series of ISPs connected to each other, and which are transmitting and receiving information. And it is like you will be going through this maze, and this is pretty complicated. I've shown it very simply, but it's pretty complicated how these connections go. But that is an ISP outlook. No need to worry about it. All you need to know is the internet is going to be a vast collection of ISPs, and you will use a wireless router in a SOHO setup to connect to it. You can use a wired router as well. If you do, then you won't be having the ability to connect your mobile phones and other wireless devices. So there will be a router which has got maybe a built-in modem, right? A modem is going to do the basic modulation and demodulation. It will convert in basic terms. It converts the signal which is coming in from the ISP into a format which is compatible for the rest of the network behind, right? The modem is simply going to do signal translation. Now, your router is going to do the function of sharing this one internet connection across multiple devices on the LAN. That is the main function of a router. Okay, so your modem, okay, hold on, this modem is this, your wireless router is this. So maybe because this is placed here, maybe you'll get confused. So your modem will be there, your router will be there. In some cases, like, when you use a BSNL connection or an MTNL connection, what happens? You don't have two devices, you have one device. When you take a broadband DSL connection from them, from BSNL, MTNL and all, right, over your telephone line. So this modem is built into the router, right? But the function is still there, right? Now, this is going to throw wireless signals for all the wireless clients. That is one of the functions. It will connect using an Ethernet cable or a network cable to a switch. Now, the switch should be connected to all the local computers, your desktops, your laptops, anybody who wants to connect in a wired way, right? So if you connect wired, the connection is more reliable and is more high speed and more secure compared to wireless. Wireless is more convenient and more portable, right? But the speeds will always be less for wireless if you're connecting wirelessly, and it is also going to be relatively less secure, right? So if you want high performance, high security, I'll always go for a wired connection as opposed to wireless. I may also have a network printer. I may also have a server on the network. In a typical home setup, you may not have a server, but maybe what kind of a server could this be? This could be my payment gateway server, or it could be a billing server where I generate my bills and all that, or it could be my CRM server where I'm doing a lot of customer activities, and all the customers' data I'm storing in the CRM server. Maybe this is my internal website, like all the people are accessing, or maybe this website is also hosted for people outside. So anybody who wants to access, they can come and access me here, right? Instead of hosting it on GoDaddy or something, I can have my own web server here. Or maybe this is a file server where I'm storing all the files, and all these files are being accessed by people here and by people from over the internet. There are ways to do it. So your server is anything, any piece of computing equipment which provides a service. What the service is, it's up to you to decide. And you do not absolutely need a switch like this. This is an Ethernet switch which interconnects all the devices on the LAN. This acts like a central focal point. It will have like 8 ports or 16 ports or 24 ports. It can support these many connections at any given time. Now, it is not necessary for you to have a switch. You are likely not having a switch at your home. All you have is a router. And the reason you don't always need a switch is because the router by default has 4 ports anyways behind it. You can just check your routers. These 4 ports are meant to connect up to 4 different devices. And this is apart from the number of wireless systems. There is no limit on the number of wireless systems, but typically you'd only be able to connect maybe anywhere between, I'd say anywhere between 3 to maybe 5 to 7, something like this, depending on what everybody is doing. There is no limit. Nobody is going to tell you can connect only 4 people, 5 people. When you connect directly to the router, there are 4 ports, so you can connect 4. But if you connect a switch in between, then you can connect, as many as you want. Then you can connect another switch to this and connect as many as you want. Right? Clear so far? Is it making sense? If it is making sense, type in MS so we can move forward. Yeah, great. So servers and data centers. Now, let me just explain you a few terms. Now, this again is not in the syllabus per se, but then if you're going to work in the real world, you need to know this stuff. You can't just know just about, computer networking and say, hey, I know about CCNA. I don't know about how servers work or, how it is structured in the real world. So when you talk about servers, some of the examples of servers are file servers, where you want to share a file or a series of files with somebody else within the same organization, or maybe you want to share it with somebody on the internet. Typically, we use less and less of these days because we have a lot of cloud storage. This was not there before. Cloud storage in the form of like Dropbox is there, then Google Drive is there. So many options are there where you can save those files and then give a link to people to download. Like I'm going to do now. I'm going to share probably tomorrow or day after. I'm going to share you Cisco packet tracer links. I think I've already shared you, the official textbooks for CCNA. We're using a Dropbox link. So all of this is there. But many organizations still use FTP because, FTP stands for File Transfer Protocol. They use FTP. They'll set up their own server in the LAN, and this server will serve files. Maybe internally, it will serve files. These are all the clients, and this is the server. And maybe this server contains sensitive data that cannot be put on a third-party server outside. I don't want to put all of this data which is there. Maybe it is just information that is meant to be consumed by the company employees. So there are a lot of reasons why I would want to have my own storage. Web server. Now, what is a web server? A web server is nothing but a website. It is a machine which is serving you a website. So there'll be a website that you're viewing. So maybe whatever you're seeing when you open google.com, that is coming from a Google server. It is a web server. It serves you web pages. Think of this as server serving you files. Web server serving you web pages. And what protocol does a file server use? FTP. Now I'll come to what protocols are. What protocol does a web server use? HTTP. Now, if you want secure, now HTTP is nothing but, when you open up your PC and you want to, browse google.com. So what is the language or format in which your PC and Google exchange messages so that when you open google.com, you get google.com homepage and you get searches. So there is some communication going on between the PC that you're on and the Google server, for example, right? So whenever you browse a website, the communication goes back and forth in a particular format that adheres to a particular standard. That standard is called as HTTP or a HTTP protocol. When you want to do this communication back and forth securely, you will use a modified version of HTTP called as HTTPS. That means more secure websites. So maybe nowadays, Google has also become HTTPS. Facebook is also HTTPS, Facebook fb.com, and Google is also google.com. Any social media site you go to, that is completely secure. So what does it mean when you say it's completely secure? It means that, and typical best example, if you ever net banked before, sending and receiving money on the internet, just typically, So this is also secure. So any data, what is the meaning of security? Any data that your PC sends to the Google server and any data it receives back, both of this, all this flow of data in one direction and the other direction is completely encrypted. It means it is encrypted in a way. It is like I am going to lock something up in a box and send it to you, and I have a key and you have a key. So you are the only person who can actually open the box. The other people can see, they can shake the box about, they can try and understand what is inside the box, but without a key, which I have one key and you have one key. I'm just giving you a very basic example. So I've got one key, you've got one key. We are the only people who can, decrypt this data and see what is going on, right? So your HTTPS is nothing but HTTP secure. That is a protocol which is used by net banking and Google and Facebook and all. And how do you know you're using HTTPS? Let me just show you quick. See, now here we are. When I go to Google, I'm not typing in HTTPS. Automatically, my machine is going to negotiate with Google, and Google is going to say, hey, let's do it the secure way, and automatically I'll find a lock icon out here. When I click on this lock icon, it says connection is secure. When you click on certificate, it's going to give you some data about what kind of security certificates Google server is using and why does your machine trust it. So there'll be a lot of these things. These are all based on cryptography. They are based on concepts of security, cryptography, cybersecurity, and all that. So there is a lot of details out here. Right? This proves the certificate. I'll equip it very brief. This certificate that you just saw proves that what you're looking at is actually Google. What if there is an imposter who's taken over google.com domain or maybe something like that, and maybe those people just put in some malicious spam links or something? How do you know? How does your machine know that the browser the browser which is opening up google.com is actually from google.com? Suppose you call me and you call me on a different number. I give you a new number, you call me on a different number, somebody calls me on a different number. How do they know that it's really me? Right? That is the thing about HTTPS. So keeping all the communication secure. Even when you talk about facebook.com, all of these are secure and it happens automatically. You see a lock icon here. Getting back. Email servers, yes, to send and receive mails. They'll be using popular protocols like SMTP, POP3, IMAP. A database server is where you're going to, when data becomes too large to handle, you're going to use a database like SQL, MySQL, and all that. And those, those pieces of information will be neatly arranged in a database and used. So there'll be a dedicated server for this in many organizations. If a database is big, it is critical, it is important to you, then you'll have a separate server instead of doing everything on one server. Application server. An application server is typically again used in conjunction with a database server, where you will, have a master application on the server, maybe on this server, and all the client applications on your within your organization are going to connect to this application and then talk to each other. So there'll be like a mother application on the server, and all the other application versions on the clients would be like client application or child applications. All of them will network with the mother application and talk to each other. That is a typical application server. For example, VoIP. I don't know if you guys understand. Maybe a chat server. Maybe I have a local, instead of VoIP, let me give you the example of chat. Maybe I have installed, I don't want my chats to go outside the organization, right? So I don't want that to happen because I believe, that is going to compromise my organization's, security. So I want, but users, maybe I've got 100 users and I want all of them to chat with each other. How do you do that? I will set up a chat application server application out here on the server, install it, configure it, and all that. And then I'll install the client chat application on all the systems, and all the systems will authenticate themselves, log into this server, and then through the server they'll talk to each other. This is a typical example of an application server. A DHCP server, I'll come to later. It is where you hand out IP addresses. Now, if you're not familiar with IP addresses, we will get to that later. DNS server, again, it is a typical application where you convert. I'll tell you about this in brief. Where you convert maybe google.com into a number or an IP address. Why we need it, how it works and all, we will get to that later. But for the time being, remember that you punch in google.com into the browser, but that is not enough for your PC to find google.com. Computers think in binary and they talk to each other with IP addresses only. So computer A doesn't know that this is computer B. Hey, I'm computer A. Computer A believes that it is 91.16.15.14. IP address is the real identity of a computer or a device, right? So then you punch in google.com. Instead of punching in google.com, you can type in HTTPS, and this, like, who will remember this? Nobody will be able to remember this. That is why we go for a domain name that is easily rememberable. And then, but your PC, which wants to communicate with the server, it will need to convert this into an IP address. What is the IP address? Think of it as, you want to call maybe your friend Karan on the phone. So you open up your phone contact book. You don't have to remember Karan's number, but you definitely have to remember that Karan is, his name is Karan. So as long as you remember Karan, you go and check the contact book of your phone and you just, hit Karan. But then your mobile network doesn't know that who is Karan. They are only bothered about the number stored there. So your phone's contact book will have Karan's number. That number is this IP address, which is used to connect. Making sense? This is clear about DNS. I'll explain more on this when we move on, but there's just a brief idea for you to chew on. So kind of like this is your data center room. A data center is nothing but a server room where all the servers are kept, and they have like they keep it under close monitoring. Nobody is allowed here, so that nobody can tamper with the servers and all, pull out plugs and maybe cause downtime. So this is your server room typically, and this is a one rack. This is one rack. This is one rack. This is one rack. Right. So once installed, this is what your racks are going to look like, and this is how they'll be stacked. Just to give you an idea. There could be a router and one, layer of this rack. Then there'll be a metal tray or a metal sheet, and then you'll have a firewall. Then you'll have a switch. Then you'll have rack mountable servers. These are servers. These are the new, more modern age servers. These are, CPU-like servers are the older tower servers. You won't see a lot of them right now because, we don't use them a lot anymore. But this is how your typical server room is going to look like. And all the devices are going to be mounted on top of that. Why networking? This is very, very obvious. You're able to send and receive money instantly. Both of you guys sent me money instantly. That is the power of networking. You can buy stuff and sell stuff online, OLX, Flipkart, Amazon. You can do real-time business. I can become an Amazon seller. I can sell from Alibaba's, all of Alibaba or AliExpress's products using drop shipping, maybe on an Indian platform, right? So instant real-time business is possible. Instant communication is possible, like we're doing right now, and instant information is available, like Google searches. So what are the different types of networks that you keep hearing about, but you're not very sure whether it is a LAN, WAN, or a MAN? Now, first step, the classification of networks is like the people give you a lot of bull saying, hey, there is LAN, MAN, WAN. Like there are three major things. One is a LAN, one is a MAN, and the last thing is a WAN. People will also tell you some things about PAN and a lot of different other items which are like real, but it's far too confusing because there is no exact definition of each network. There is an indicative definition and that's it, right? There is no exact definition of what is a LAN. It does not matter, right? I'll show you how. Now, a LAN is nothing but a local area network. The abbreviation for a local area network is called as a LAN. Now we call it local area network because it will span maybe the same room. The size of a LAN could be the same room, two systems right next to each other in the same room, maybe a cyber cafe, right? For example, or maybe you have two desktops or two laptops connected, in your college, laboratory for practicals, computer practicals. So that is a typical, in the same room, everybody is connected together to the same network through a switch or something. That is a LAN. Maybe the same room, maybe the same floor, maybe even the same building, 10 floors, everybody is able to talk to each other because of networking. So all of this is LAN. Like there is no fixed, you can't say that, hey, this is a LAN and this is not a LAN. So whatever we are learning right now is for you to, have an idea of generally what a LAN looks like. But then if I have just one PC connected to a wireless router, that is also LAN. And if I have like 10 systems talking to each other, or 100, 200 systems talking to each other as part of the same network across maybe 10 floors, that is also a LAN. Right? You're communicating locally, that is more important. And typically you will use technology like Ethernet cables, fiber cables, and Wi-Fi signals to be able to connect to each other, to be able to form a LAN, create a LAN, and then have PCs talk to each other. Campus area network. Now assume, right? So a typical example of a LAN is this, right? These are all your LANs. Suppose I have an educational institute, right? Educational institute which has a number of buildings. Take for example your own colleges. Like there are multiple buildings. Each building has its own LAN, but ultimately all these LANs belong to the same parent company, right? So they all belong to your college. So they will all connect to the same servers. So if your internet connection is coming in, then the internet connection will be, shared across all the buildings. There won't be a separate internet connection for each building. Maybe you have a file server or maybe an assignment server where all the college students' assignments are kept or whatever, So when you do that, the server is going to be shared across all the systems. So when you enable that kind of a sharing, then it becomes a campus area network. Campus area network is nothing but multiple LANs tied with each other, which are all belonging to the same organization. So if you have a building LAN, you have building A, which is there, and then there is building B. If both of them belong to you, you will connect them to a bigger LAN, right? Because resources will be shared. People will want to chat. People will want to send and receive files and all those things. But if you're building A and there is another building B which is owned by somebody else, you are likely not to connect. Right? Why would you connect to somebody else and share your business data and all that? Doesn't make sense. That is not a CAN. A CAN is all buildings with LANs belonging to the same organization. Maybe a big IT park, or maybe a big, college kind of a thing, college campus. So typically you will use something like fiber cables and maybe Wi-Fi connectivity to establish connections and form a CAN. Now, metropolitan area network is actually, the abbreviation is MAN. It is nothing but typically the, connection of systems or networks or LANs. Think of it as connecting LANs across a small city or a town. Right? So your MAN in this case, if you see, this is connecting all people across a particular. So this is Delhi, this is Delhi, this is Delhi. Everyone is in Delhi. So your MAN is connecting everybody across the span of a city, metropolitan city, or maybe everybody in Margao, maybe everybody in Pancham, maybe everybody in Goa, because Goa is a small state, right? So you connect everybody together. What is the typical use for this? Two use cases. One is where there is a company which has multiple, locations within the same city, maybe an office in Margao, maybe an office in Panjim, or maybe two different cities within the same state, and you want them to communicate. Right? So you want them to communicate. So you'll build a private network or you'll rent out something from an ISP and you will all be connected to the internet and you will talk to each other. That becomes an example of a MAN or a metropolitan area network. The second example is, I don't know, how many people, how many of you guys have fiber connectivity at home right now? How many of you guys are, accessing this through fiber? If you're aware of that. Okay, Noel says he's on fiber. How about you, Alicia? Yeah, all of us on fiber in Goa, I think. Yeah. So when you are connecting through the fiber thing, like your ISP has connected your network to somebody else's to somebody else, and they formed what we call as a loop. They create a huge loop where there are a number of subscribers, everybody is connected to each other. So and data can flow in this direction or in this direction. So some node fails, something fails here, you can still send data this way. So there is redundancy, right? So this kind of a loop thing which a ISP builds is an example of a metropolitan area network. Like all of us are connected. Obviously, we can't access each other's LANs. Like I can't access your system, you can't mine. Obviously, because we are all separate paying customers. We are not allowed to connect with each other. Like I cannot just think of this. It's not like a CAN. So your ISP will have rules in place to prevent you from accessing other people unless and until you use a service to do it. So don't think of this as a bigger LAN, right? So a MAN is where different LANs belonging to different organizations are brought together. Say, for example, a internet service provider across a small city or a town. Typically, you can use Wi-Fi connectivity or fiber cables to achieve that. Okay, just give me 1 second. Okay, I'm back. A wide area network, or also called as a WAN, is nothing but a network type which spans an entire state, maybe the entire state of Goa, maybe the entire state of Maharashtra, or any state in India, or maybe a country, or maybe entire continents. Basically, it is nothing but your internet, right? So if you're contacting somebody in Bangalore or maybe somebody in a different state altogether from out here, it is nothing but an example of you communicating over a WAN. So typically, when you look at this, people, this is a MAN which is tying up everybody in Delhi, and people in Delhi are talking to people in Bangalore. Data has been exchanged. That is over a WAN. So now you can't exactly say that this is a CAN, this is a MAN. Now I hope you guys are getting the point. Exactly what is never important. Nobody is going to drill you on this in an interview, but you have to know which one is required where. Like, can we call this a LAN in a safe way? Can we call this a CAN? Does it make sense? Do we know what a MAN is? Do we know what a WAN is? Generally, there'll be some level of overlap. Now, computing versus communication devices. Now, computing devices are nothing but your devices which generate and receive traffic. So, say for example, your PCs, desktops, laptops, your phones, tablets, servers, storage devices, right? So wearables, like you have smart wearables these days, smart watches and all that, right? They're also connected to your wireless router. So all of those end devices which send and receive traffic, they're called as computing devices. All of these. And communication devices, on the other hand, are stuff like routers, switches, firewalls, modems, network interface cards. We will come to this. A network interface card is nothing but a device within your PC which allows you to connect to a existing network interface card. So this allows your PC to connect to an exist. So whenever you see that network port or the RJ45 port on your laptop, where you plug in your Ethernet or network cable, that port is there because there is a network interface card inside your laptop or your desktop, which is fused to the motherboard. If it is a desktop, then you can connect, open it up, and then connect an external network interface card and remove it whenever you want. With laptops, it is usually built in. It is built in. And also when you connect using Wi-Fi to an existing network, that is also an example of a NIC. So your NIC can be wired or it can be wireless, as simple as that. So all of these devices like routers, switches, firewalls, modems, network interface cards, access points, I'll come to what access points are later, don't worry. So all of these devices do not generate their own traffic for the most part. What do? They are just intermediaries that carry the traffic of computing devices. So these guys are going to generate the traffic and these people are going to carry it. Now, these terminologies, if you actually search on the internet, you won't find them. This is something that I have put in as my own, so that it is further simplified for you. That's why I said at the start that I'm going to explain what do you mean by devices. You remember? I had said that these are devices. Networking is nothing but devices interconnected to each other. So these kinds of devices. So these will generate the traffic and these people will carry the traffic. Right? Clear so far? If we are crystal clear, type in CC for crystal clear. Great, guys. Set your, you're able to save a screen set just to, instead of panelists, say panelists and attendees. So you can see the other person's chat and, life becomes a lot less lonely for the time that we are talking to each other. Okay. So what we'll do is we'll take a small break, if you guys don't mind, because now we have started with actual learning. I want it to be intense, and intense, small, short, intense bursts. So let me look at the time. 1 second. 7:43. So 7:50 a.m. The time right now is 7:44 on mine. So 7:50 a.m. we come back again. Okay, so don't disconnect the session, just stay in the session. And you can just, come back to it whenever you don't close your laptops, don't disconnect the session, just, be back in 5. Take a small break, walk around, drink some water, and correct your posture. I'll see you in 5. Hey guys, I'm back. If you are able to hear me, give me hi. And if you're back as well, let me know. Okay. Noel, Alicia, hi. Just sharing my screen again. Okay, if you're able to see the presentation, type in PPT. And the reason I kept asking about this presentation thing again and again is because there have been at least 1 or 2 occasions where I have, completely lost touch of the fact that people are not able to see my screen, and I've gone on to explain them something in detail for about 15-20 minutes. And then people used to WhatsApp me saying, sir, we can't see your screen, So I don't want that kind of a thing happening. That can be frustrating. Yeah. So let's move on to protocols. TCP/IP, you must have heard of these terms. Let's take a deep dive into what these really are. Now, what is a protocol? Now, communication happens between a sending and a receiving device if they speak the same language only. We can communicate because both of us are able to understand English, right? So if I speak English and you speak maybe Marathi, maybe you speak Hindi, then communication is not going to be possible. Right? So this common language which is there, very loosely we call it as a protocol. Like I'm trying, see, the way I teach you things is like I'm going to give you very simple and at times borderline ridiculous examples, because that is going to, really simplify the whole thing. So whenever you're learning something complicated, if you can just, repeat it back to yourself in a very simple way, you'll retain that information. That is how you simplify learning. It's not, you have to, learn this whole thing by heart and then, vomit it out or pick it out in an interview. That is not going to help you. So if you want to really succeed in a field, just try and make sure that you're able to simplify whatever you're trying to learn and, internalize it in a very simple way. Store it inside in a very simple way. So when you tell it to somebody else, it comes out differently. It doesn't come out the same way. So to make that easier, I'm going to give you a very simple example, very sometimes stupid, sometimes ridiculous examples, because those actually stick in your mind. There is a reason for that. So a protocol is nothing but a set of rules followed by both the sender and the receiver. Now, in the real world, when I say this sounds fancy, but real world, sir, what does it really mean? I mean, what happens? You say rules. I mean, these are not traffic rules. So my PC and the web server, how do they follow these rules? Now, in the real world, protocols are nothing but pieces of code or software which are implemented within the operating system itself. So when you buy a Windows 10, Windows 7, Linux, Mac operating system, any device, Android, all of them already have these, protocols, and they know how to communicate, connect to a network, communicate on a network. They know everything, how to take an IP address, how to, open up, provide HTTP support, all the protocols, HTTP, FTP, sending emails, receiving emails. All of this is already built in, coded into your operating system, regardless of the device you're using. That is for communication devices. Whereas for the other types of devices, the communication, and I don't know what the other name was, computing. Yes. So I don't use this terminology a lot. So computing devices, like the operating system will handle it, and communication devices, again, the networking hardware will have this coded inside of it. So the router knows what to do, switches know what to do, firewalls know what to do when you ask them to deliver a packet to the internet, right? So we are all talking the same language. Say, for example, you're accessing web pages, your web browser is communicating with Google server, maybe using HTTP, like I explained before. And maybe you're using email clients, or maybe you're using stuff in your browser. You're just opening up google.com or gmail.com. So you're using protocols like maybe IMAP, SMTP, POP3 to communicate with the email server back and forth. So there is a small backstory to these this whole protocol drama, which I think might be interesting for you to know. Now, back then, in the internet was invented around the late 1970s, early 1970s, mid 1970s, maybe. So the internet, like we know it now, it was a project by the agency in the US of A, the United States of America, called as DARPA. There is a US Department of Defense. This is like the Ministry of Defense out there for the US government. They had a project called as DARPA, Defense Advanced Research Projects Agency. So this was a project that was aimed at connecting all of the different military sites together for communication. Back then in the 70s, can you believe it? 41 years back, they already had this working, right? So they were very, very advanced, and they connected all the military sites together. So somebody saw this, and they must have thought, hey, if we can do it for military sites, can we connect people and organizations together? Maybe find a civilian use for this. That is how the internet was born, and then they adapted it, right? So when they did it, there were a number of protocols which were invented by different vendors to solve proprietary or own problems the way they saw it. Like if I invent something, I'll invent something to solve a problem that I think is important, and in a different platform, in a different way, right? So something called as SNA was developed by the IBM company. IPX, SPX protocols were invented by Novel Network company. Apple Talk, I don't know if you guys know this. Apple Talk is a protocol which was invented by the Apple company, and then Microsoft invented something called as NetBIOS, so on and so forth. So each and every company, people knew that internet was the hot thing, and they needed protocols in place. So everybody started running around in all directions. But this obviously will cause problems, because if tomorrow I have a Microsoft device, it is not going to talk to an IBM device because they are using two separate languages. We need one standard protocol. So ultimately, Department of Defense, DARPA is the project name, and ARPANET is a specific project which they executed for the internet. So they came out with a protocol stack, not one protocol, but a protocol stack called as TCP/IP, which eventually became the standard for the internet. So today, if you ask anybody what the internet runs on, like what protocols do we communicate on, why are you and me able to talk through the same Zoom application right now? It's because we all follow TCP/IP, right? So if you have a wireless device, wireless mobile phone, maybe an Apple iPhone, and maybe you have a wireless, a smart device like a smart AC or a smart fridge, all connected to the wireless router, everybody's talking to each other. So that is only possible because all of these devices are TCP/IP compliant. So TCP/IP is a language spoken by all devices over the internet. So you look at this, whether regardless of the operating system, regardless of the type of device, everybody speaks one language, TCP/IP. That is why we are able to converse with each other regardless of the operating system, regardless of what else is going on. So what is a TCP/IP? When you say TCP/IP, TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. Just give me 1 second, guys. Okay, I'm back. So TCP/IP is not, like I said, the full form of TCP in this case is Transmission Control Protocol, and IP stands for Internet Protocol. Now, these are two specific protocols within the whole TCP/IP stack or suite. When you say suite, it is a stack of protocols, right? It is a bunch of protocols, a group of protocols, not just these two. So if somebody asks you in an interview, hey, what are the two protocols of the TCP/IP suite? They are not just two, there are multiple. Just give me 1 second, I need to turn off the alarm. Yeah. So there are not just two protocols in there are multiple protocols. And these are just an indication of how many protocols there are, right? There are more protocols than you can possibly count, each having a specific function or a specific attribute. Each of these protocols is doing a particular job that the others are not, right? Think of it as, you need 11 players in the Indian cricket team. Or maybe you have like, I don't know how many players are there in the football team. I think there are 11 maybe. So everybody has a specific function. What a defender does, the guy who's maybe the left wing or the right wing or whatever they call it, that the striker is never going to do, right? So everybody has a specific role to do. TCP/IP suite is that set of protocols, right? So there are some protocols like DNS. I've explained to you what DNS does. It converts user-friendly website names into IP addresses, because when your PC wants to communicate with the Google server, this is your PC, this is you, and you want to connect to the Google server, this can only happen over an IP address. The names you're giving to the domain server and all, that is only for your convenience. That name does not mean anything unless it is converted to an IP address. So your PC needs an IP address. Whatever you do, any connection you make, be it Skype, Instagram, whatever you are accessing, over a network, your PC needs an IP address. Even if you're communicating between two PCs on the same LAN, they are connected to the same switch. For communication to happen between the applications, the IP addresses should be there. They'll communicate with each other using IP addresses. DNS is going to help you do that, right? So TCP, that is DNS. Now, TCP is Transmission Control Protocol. It is a protocol which I'll not mention the layer of the OSI because it will be a little confusing for you right now. But TCP generally is a reliable way of sending packets from point A to point B. Think of it as you want to send a good, a very precious parcel from maybe Bangalore to Goa, and you want it done without damage, without, it's very sensitive. So, and it should go in the best condition possible. Maybe it's a piece of antique furniture, for example. So you will engage somebody like a Blue Dart. Now, the problem with a Blue Dart is it is going to charge you, they are going to charge you a bomb. But the good thing about Blue Dart is they are also going to do a good job of the delivery and they're going to give you great value. That TCP is like that. They're not going to call you up and say, hey, we just lost your parcel, so we are sorry about that. Somebody like, you'll never send something like that using maybe a local, I don't know if you've heard of this. There is something called as Vichare Couriers in Mumbai. There is maybe XYZ Couriers, maybe Santosh Couriers. Why would you send it through that? Maybe professional couriers. You can send a document maybe, but if it is something critical, something very important, it should be reliably delivered and people should not tamper, like, something like maybe a FedEx or a Blue Dart, right? So TCP is like that. So if you want to send data from one point to another point, A to B, reliably, without errors, with guaranteed way, then A to B communication can be done with the help of TCP. Now, UDP, on the other hand, is similar to TCP. They work at the same level. So when you choose an application, the application will choose whether it needs to use TCP to communicate or UDP. So you might think TCP is a good guy because he's more reliable and UDP is not. Like, it's not the case, because TCP helps you with more reliable connections. UDP help you with real-time fast connections. Right? So maybe you are, I'll give you an example. Maybe you are taking your grandparents or your parents in a car. Maybe you're taking them for a hospital checkup and all, right? When you go with your family in a car, if you observe, your priority is not, speeding. Your priority is more or less, avoid any circumstances, avoid accidents, avoid rash driving, and just take them safely from point A to point B. That is an example of TCP. Their reliability is important for you. Speed is not. On the other hand, when you go, when you're rushing for an interview, or maybe you're going out with your friends, playing safe is the last thing on your mind. Like, you want to do, you want more speed, you want more this thing. So you want things to happen faster. You're going for an interview, you want to reach that faster, right? Because you're already late for work, stuff like that. There, UDP comes into play. Think of it as a UDP. I'm just giving you examples, right? So these are two protocols working on the same level. So your application will pick TCP if it wants a reliable connection. If you pick up UDP if it wants real-time faster connections. Like, for example, real-time streaming. You're streaming something from YouTube or something. So you don't want it to be reliable. You want it to, even if like you're watching a video which is like video is nothing but a series of frames, right? Image frames one on top of each other, played after each other. Now, suppose there is a loss of a frame in between. You don't want that frame which is lost on YouTube or maybe IPL to be shown back to you again. You're okay with losing the frame, just keep moving real time. It's more important for me to see things real time. That is UDP. Now, IPv4, IPv6 are two versions of the IP protocol or internet protocol. IPv4 also we are going to learn. IPv6 also we are going to learn. Now, www, that is World Wide Web, or HTTP is used to browse. HTTP is used for communication between your web browser or your system and the remote Google server or Facebook server or whatever web server you're trying to access, and you want to do it securely. SNMP is a protocol that we're going to look at maybe towards the end of this program. It is not in use a lot anyways these days. It is used for you to manage all of your networking devices sitting in one place easily. And FTP and TFTP. FTP stands for file transfer protocol. TFTP stands for trivial file transfer protocols. Both of them are used for transferring files. So let's look at the OSI model. Both of you guys are familiar with the OSI model? Or are you hearing about it for the first time? I think Alicia, you've gone through videos, so I think you are more confident. Okay, Noel is hearing for it for the first time. Absolutely. So, and guys, before I forget, because you're part of the permanent, 30-day program, so I want you to, accept the request for invitation, the invitation request, sorry, for the Facebook group, where all these videos are being stored, right? Because if we want to reference a video, then it is going to be there, uploaded maybe before 11 or 12 the same day. Yesterday's video is already uploaded, but I think I sent an invitation to Alicia. So Alicia, you can just log in onto Facebook. And Noel, you can also, click on that group link, which I've sent in the group, and have access to the videos. Like, the videos are going to be there for a lifetime, but I just want you to access and see if you're having any problems with that. Right, so let's look at the OSI model. Now think of the OSI model as a burger. Like, a burger can have a number of layers of good stuff. You can have the veggies, and then you'll have the patties, and then you'll have a layer of cheese and maybe something else and all that. So total of, I'm showing this to illustrate the fact that the layers, the OSI, OSI stands for Open Systems Interconnection. It is a standard that we used to use and we still use theoretically now. So it is comprised of layers. So there are 7 layers of the OSI. Conceptually, this is a conceptual model, theoretical model. This is not a real model we use. I'll show you how we can use this as well. So the numbers of the layers are non-negotiable. So for example, when you say layer 7, you cannot count from bottom and say layer 7 and top one is layer 1. You can't come from top to bottom, bottom to top. You will always count from bottom to top. Layer 1, layer 2, layer 3, layer 4, and the topmost layer is layer 7. So layer 7 is the application layer, 6 is the presentation session. So I want you to be able to remember all the 7 layers of the OSI, because this is something that this is a very basic question anybody can ask you in an interview. Right? Make sure that you remember all the names. And if you can just, I'll show you an acronym for this, which will make it easier for you to remember. But just make sure that you don't confuse the your names and the layer numbers. So the, session layer, for example, will always be layer 5. See, this acronym out here, all people seem to need data processing. So what is it? Application, presentation, session, transport, network, data link control, and physical. Right? And your OSI layers, now your OSI layers, which we are talking about, these 7 layers form what we call as the OSI model. It is a theoretical model or a conceptual framework which defines what functions need to be done when you're sending packets from point A to point B. Maybe you're sending packets from this PC over the internet to point B. So there is a series of steps which need to be executed to send data from A to B. So what are the different functions involved? Those are all grouped into different layers, and those layers form the OSI stack. So it groups the layers into 7 functions into 7 layers. Now, the important thing is each and every of these layers is independent of the layer above and independent of the layer below it. So having said that, it means that each and every one of them, that is the application layer, the presentation layer, the session layer, all of these do not talk to each other, rather they talk to each other, but they do not depend upon each other. Like what application does, suppose you're sending data, application will process the data, send it to presentation. Presentation doesn't question application. Hey, this is there, that is there. So, any corrections, blah, 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 all of this. Presentation will do the data and send it down further. So on, so forth, till data comes all the way down. Right? I'll illustrate this with an OSI model diagram as well, probably tomorrow. But what I'm trying to say is all the layers do their functions independently. They do not depend upon each other. So once application is done, send the data to presentation. Presentation is done, send the data to session, so on and so forth. I told you that TCP is a reliable protocol. So when you say TCP is a reliable protocol, that that reliability is generated by an error recovery service, which happens at layer 2. So TCP works at layer 4. This also you will learn probably tomorrow. UDP, TCP both work at layer 4, but they provide reliability from point A to point B. From point A to point B, data can be sent and received securely without missing a single packet. That is provided by them, but that again is because there is some protocol at the data link layer level, which is providing that service. So you can say that each and every layer is providing a service to the one above it. Right? That is the reason I mentioned this and given this example as well. So OSI initially, the story is OSI initially came out as a competitor to TCP/IP, but then it never got steam. It never was successful. So what has happened is TCP is very much in the world, like I said, OSI is not, and the reason is that OSI was never developed that way. And then today we use OSI still along with TCP/IP. How? We use OSI to build theoretical models. When we are troubleshooting, we use OSI. When we are explaining a concept or trying to understand the networking concept, we use OSI, right? So I'll show you examples of that. Yes. So we use it to model the explanation. So if I want to describe how data goes from point A to point B, what communications are going to happen? Point A to point B. Be it a local LAN, or maybe it is a switch, local LAN, or maybe this is the internet cloud. So what is going on here? How does communication flow? What happens step by step? So for all those explanations, to model those explanations and give you a context, OSI is used. Mostly for theory, troubleshooting logic, so on and so forth. You'll learn more about this when we do it. Maybe when we work on troubleshooting and all that, I'm going to tell you about these layers, Okay, this is a little intense. So what we'll do is we will try and do this, and then we'll call it a day. Right? So how does the OSI model actually work? Now, what is exactly happening here is we have the 7 layers which are showed in different colors in between. Now we know that the OSI is a theoretical model. Again, just wanted to know, I just turned on my fan a little more. Are you guys able to still hear me clearly, or is it more disturbing? Is the sound disturbing you? Clear. Awesome. Awesome. So then assume that this guy is the sender. This guy is a receiver. So A is the sender and B is the receiver. So whenever somebody is sending, there will be an application here. Maybe there is a browser window, right? So this browser window, you're going to punch in google.com or maybe santosh.com or whatever. And that data is going to be then sent to layer 7. From layer 7, it will be sent to layer 6. Layer 6, it will be sent to layer 5, 4, 3, 2, 1. Then data comes out of here. It will be a series of zeros and ones. Why? Because computers always talk in binary. They never talk in any other language apart from binary. So whatever you wanted, whatever the data as information is converted into a stream of zeros and ones, physically sent across maybe the local network or maybe the internet. Doesn't matter. It is then sent to this guy. Then when it is going up, it will encounter a physical layer first, then the data link control layer, then this layer, all the way to layer 7. Finally, all the data is going to be cleansed and then given to this receiving side. And then this will actually go to that application part, which is indicated. Like, for example, if you're sending a web browser request saying google.com, please open google.com. Here, when it goes to the Google server, maybe this is the Google server. So it will go to the module of Google, specifically out here after crossing layer 7. You go to that module, which is handling, all the web sessions. Because that Google can also provide you Gmail, or Google can also provide you Google searches, right? So whatever it is that you're doing specific, there will be a specific module inside Google servers which will be handling that particular process. How will you do that? You'll be doing it through this, right? So this is keeping it very, very simple. Now, what is also happening is at each and every layer, as data is passing down, most of the layers will add additional information to the front and the back side of the data. Anything that is headed to the front side of a data is called as a header. Anything on the back side is called as a trailer. Now, some layers don't do it. Like, for example, application layer will do it. Presentation doesn't, session doesn't, transport does, network does, data link does, right? So we won't get into the specifics, but generally most layers add information to the data as it passes by. So think of it as you covering it up in a wrapper. So this guy, layer 7, puts it in a wrapper, sends it. This guy puts his wrapper. wrapper, all the way till there becomes a big wrapper, which is a 0 and 1, combination of zeros and ones. This data is then sent across to this guy. Now, listen carefully. Now, level 1, that is on layer 1, that is the physical layer. This guy will remove whatever is there, which was inserted by the corresponding layer at the other end. Then data is sent on top. Now, data link control layer, that is DLC, is going to control the data, the header and the trailer. It is going to remove the header and trailer, which was there before. Similarly, so on, so forth. Now, the process of wrapping something up is called as encapsulation. Wrapping data with a header and with a trailer is called as encapsulation. That is usually done when sending, and when receiving, you will clean up the data and you will de-encapsulate it by removing the header and the trailer. That is called as de-encapsulation. Now, if there is interaction between two layers, it is called as same layer interaction, layer 7 and layer 7. And if the interaction is between layer 7 and layer 6, it is called as adjacent layer interaction within the same PC. Right? So, yes, this is an example. Like you see here, data is there. Data has been given by the session layer to the transport layer. TCP quietly adds a TCP header to it, and maybe some trailer as well. Then this data will go all the way down to the IP layer. That becomes the data for the IP layer. This whole thing becomes data. IP layer will not change. Layer 3 will not change this information. It will instead, this is constant, it will add an IP layer. Then it goes further down, it takes a data link layer, right? So the name, there is a particular name that we give to each and every layer of data. When it is a physical layer, we call it as a bit. When it is a data link layer, the unit of data here is called as a frame, bits frame. Then you have layer 3, that is network layer, that is referred to as a packet or a datagram. And lastly, but not the least, transport layer, the unit of data is called as a segment. So you just need to remember these 4. Even if you go through all of this at one go, you'll be able to remember it just fine. And these notes are going to be yours as well. Like I'm going to be sharing with you for all the full-time people, who are part of this course. You'll be able to access them. Just give me a day or two. I'm just editing this. I'll be sharing you the latest copy very, very soon. Meantime, if you want screenshots, just make sure that you're taking screenshots as we go. This is a little complicated. I would like to, give this more time and do more justice. So this is probably something we will take up tomorrow. So do you guys have any questions that I can answer? Alicia is saying no, not for now. Noel is saying no. Okay, and just a quick tip, just make sure you're revising everything. Maybe once during the day and once in the night before you go to sleep, because that is going to, without revising, like all of this concept is good and you're learning new things. Without revision, you're really not going anywhere. You will not be able to retain a lot of the information because all of this is new information for you. Right. So on that note, then I will let you guys go and we will see each other tomorrow, 7 a.m. And if you need me for anything, please feel free to WhatsApp me. And take care and stay safe, guys. Bye-bye. Bye, Noel. Bye, Alicia. Thank you.